Hey there, today we are going to talk about a video player implemented with XState. This video will be a bit different than the other I made about examples from XState by example, because I don't think it's a great idea to build the video player from the ground up, as it would take too much time. So instead, we will review my implementation, and I'm sure that you will be able to find some interesting things to note about XState in my implementation. So let's talk about it. If you want to find the example, go to xstatebyexample.com. Then there is a video player example there. It's an advanced example because it's kind of complex from the UI and from the state machine side. And then you can see the video player there. You can stick at any position of the video, you can play, you can pause, you can click on the video and on the buttons, you can go forward or backward, you can also go on full screen mode, you can control the volume, and you can also control the video with the keyboard. So I press the spacebar or the K character. I can also press the arrow right key or the arrow left key, and you can press the F key to go to full screen mode again. This is a state machine on the Stateless Studio. It's a bit big, so we will check every part independently. The first part and the initial state of the machine is this top state. You can see that it listens to toggle, play and video click events. Then it goes to the initial loading state. This is what happens when you arrive at the page for the first time and you are asked to start playing the video. So I can either click anywhere on the video or specifically on this button. You can see that I could click outside of the button. And now you can see that you can also click on the button itself. Let's give a look quickly at the implementation side. So this is a file in which I define this video player machine. I define a bunch of TypeScript types about the events, the context, the input, the tags. These are some actions and the single word used by the machine. Then the create machine function with the contexts and the stop state we just saw, which is the initial state. So this state listens to play, video click and toggle.wildcard. Let's talk briefly about this wildcard pattern in XState 5. In the version 5 of XState, you can use partial wildcards. What it means is that you can listen to events and sub-events. The machine can receive toggle and toggle.keyboard events. But maybe you would like to listen to both toggle and toggle keyboard events and have the same transitions applied for both events. This is the use of those partial wildcards pattern. That means that toggle and toggle.keyboard events will both trigger this transition. One thing to note about this is that you need to put a dot and then the wildcard, and you can have only one wildcard in your pattern. So this is really to match the end part of a pattern. When we take those transitions, you can see that we are doing kind of the same thing, because however we start the video, we just want it to start loading and to actually play it. So these transitions all do the same thing. The play transition assigns to the current video source property in the context the video source property also coming from the context. If we check the definition of the types, you can see that in the context, the video source is a string and the current video source is a string or undefined. The reason is that while the video has not been asked to start playing by the user, I don't load the source. That way, the loading of the video only starts after the user starts wanting to play it. So this is kind of a lazy loading pattern. But you can also see that the input property, which is a new thing from the version 5, you receive the video source and the video poster as properties. We are in the React component using the video player machine. I use the useActor function from XState React to start the machine, and I provide some inputs to the machine, like the video poster and the video source. That way you can provide information from the outside of the machine and have them directly available from the beginning of the machine lifecycle. Indeed, you can use a function to define the initial context of the machine. So this is the machine definition, and this function you can provide takes the input property. So these big objects in which I provided the video source and the video poster, you can use that to construct the initial context from the machine. The benefit is that now I can fill the video poster and the video source into the context, and I differentiate them from the current value, like current video source. That way the information is available from the context, and I can use it later to assign the current video source when the user asks for the video to play. So assigning the current video source is the first step. The second step is to go to initial loading state. We will talk about that just now, but before, I want to show you that all these transitions do the same thing. Indeed, the toggle.wildcard transition also assigns the current video source and triggers the transition to the initial loading state. But what is interesting there is the video.click event. This event is sent when, I will show you, when, so this is a div wrapping all the video player, and I have an onClick event handler on this, and when you click on the video, this event is triggered. And I want to have the same behavior as the toggle.wildcard transition. However, I don't want to repeat it every time. So it would be a bit boring if I had to write that every single time, because these three transitions do the same thing. So one thing you can use to prevent duplication there is raising an event. Raise, this is a function coming from XState. This is an action builder, and this action will send an event to the machine itself. But you might know the send to over action from XState. The difference there is that send to or send from the XState 4 will send an event for the next macro step, and raise will send an event that will be executed in the next micro step. The difference there is that micro steps are executed before a state changes from the outside. So when you send an event to the machine, it tells the machine to execute it later when it can, and if it's already processing events, then the new event won't stop the execution of the already pending events. Micro steps, instead, like an event raised, are executed as fast as possible and before those events sent from the outside. The benefit is that if you send a video click event, it's like if you sent a toggle event. The transition will be taken immediately and not at the next macro step. This is a neat pattern if you want to combine several transitions together. For your information, this is a video HTML element. I provide the poster and source attributes that way, and as we said, the current video source property is undefined at first. So the video will load only when the user clicks on the play button for the first time. When you click on the play button, the source of the video will start loading. You can see that a request has been made when I clicked on the play button. When the video starts loading, we need to wait for the loaded metadata event. This event will be sent by the browser when the metadata of the video will have been loaded. The metadata are the duration of the video, for instance. So when we receive this unloaded metadata event, we send it back to the machine and call it metadata.loaded, and we gather the video duration and forward it to the machine. After the stopped initial state, when we start playing the machine, we go to initial loading state. In this state, as we saw, we start loading the video by providing the source of the video HTML element. And then we expect the metadata.loaded event to come, and then the video can play. But we don't know when this metadata.loaded event will come, so we might want to display a loader. You can see that in the initial loading state, we default to the hide state, and after 500 milliseconds, we go to a show state. Both states use tags. This is a really cool feature of XState. With tags, you can group states. So instead of checking if you are in the state A, the state B, or the state C, you can do, is the state machine in a state that has a tag like show loading overlay or show loader. So the idea there is if we wait for too long, then we start displaying a loader. We can check it in the browser by throttling the network. So I will use a slow 3G. And you can see that after some time, this loader appears. To define tags on states with XState, you use the tags property. It can either be a string or an array of tags. Delay transitions are my favorite feature of XState. With them, you can do so many things. Like this, we can delay showing the loader with just a state transitions. I find it so cool. In the React code, if you want to know whether the tag is present on the current state or not, you do snapshot hashtag and the tag you want to check. I use that to determine if I need to display this loader with the overlay. In the machine, when I receive the metadata.loaded event, I trigger a transition to the ready state. We will talk about it just now. And I assign the duration of the video to the context. That way, I can get it programmatically from the context of the machine. Now that the metadata of the video has been loaded, we take this transition and we arrive in a big state called ready. So ready is what we call a parallel state. As you can see, there are several states in ready, several child states, animation, and controls. So parallel states enable several states to be active at the same time. The objective there is to have the controls and some kinds of orchestrated animation to happen at the same time, concurrently, and be controlled by the same state machine. This is the objective of parallel states, is when you have concurrent tasks, but you want to control them and sometimes have some synchronization mechanism. For now, we will focus on the control state, and you can assume that this is the active state of the machine. So the initial state of the control state is playing. By default, the video starts playing when you click on the play button. In the playing state, there is this interaction called play the video. I override the play the video action from the React component, and I'm able to access the lexical scope of the component, especially the video ref from the React word. So then you can call the play function to start playing the video. You can see that when you hover over the video, the controls appear. When your mouse enters the video, the controls appear instantly, and when your mouse leaves the video, the control disappear instantly too. But when you hover over the video, the control continue to appear. However, if you stop moving the mouse, after 2 seconds, the control disappear. If you have seen my other video about the debouncing pattern with XState, you might recognize it, because this is what happens there. Every time you interact with the video player, you are sending events to the machine telling that you are either hovering over the element, or leaving it, or entering it. If you do nothing, no event is sent, and every time you send such an event about entering or hovering the element, a timer resets, a timer of 2 seconds. In the state machine, in the playing state, there is the hovering state and the idle state. The hovering state has a show controls tag and the idle state doesn't. There is something to note there before we start diving on how this happens. The controls don't behave the same if you are on a mobile or on a desktop device, because on a desktop you have the mouse, you can hover over elements, but you can't on a mobile. So the behavior is a bit different based on the device you use. You can see that there are some words there like is not touch device, is touch device, is not touch device, etc. We will first talk about the desktop devices, so the not touch devices. Hovering, after 2 seconds, you go to the idle state. If you are hovering when being on the hovering state, then you re-enter the state. It means that this 2 seconds transition, delay transition, will be restarted. The timer will be restarted. This is where there is this debouncing pattern applied to the video player controls. If you hover over the video while being on the idle state, you go to the hovering state. If the hover leaves the video, then you go back to the idle state. I'm simulating a mobile device. You can see that when you click anywhere on the video, the control appear or disappear. If you want to start the video, you need to click on the play button, and after 2 seconds the controls still disappear. But there is one more step. If you want to show the controls, you first need to click anywhere on the video to activate the controls. This is what happens on the YouTube player. This is the same thing, yes. Let's check how it's implemented in the machine. So this is the playing state, this is the ready state, and these are the idle and hovering states. So first, the hovering state. There is another delay transition with the 2 minutes, after which we go back to the idle state. When we are hovering, if there is a video click and we are a touch device, then we go back to the idle state. If we receive a hover end event and we are not a touch device, then we go to the idle state. If we receive a hovering event and we are not a touch device, we re-enter the hovering state with the re-enter keyword, which recreates this delay transition. This is the trick there. This is the same trick as for the debouncing pattern. You re-enter the state, which recreates all the timers you created. The delay transitions, like with the after keyword, and this 2 seconds transition will be restarted. In the idle state, if you receive a hovering event and you are not a touch device, then you target the hovering state. If you receive a video click event, there is no guard there. The reason is click events are sent in the browser after hover events. So I assume that if you receive this is that this transition has already been taken if you are a desktop, for instance. And on a mobile device, this transition is not taken, so this one will be. In the React part, mouse move leads to hovering, and mouse leave leads to hover end. By default, we start playing the video. However, the video chunks may not be loaded in time, and the browser will tell you whether or not the video is ready to be played. In the machine, there is the playing state, we talked about it, and there is also a loading state. This loading state is entered when you receive a waiting event from the playing state. Waiting is an event sent by the browser through the video element to tell you, I need more time to load more chunks of the video. Browsers are different on that. Firefox waits for a long time before playing the video again. On the other end, Arc, a Chromium-based browser, waits for a short time, and it can't load very much chunks of the data, so it gives this chunky loading experience, not that smooth. In the loading state, you expect the browser to send you a CanPlay event, telling you, yes, you can start again the video. This is a React part. On the video elements, you can set a onCanPlay handler, sending a CanPlay event in my case, and you also need to wait for the waiting event. In the machine, in the playing state, which has the idle and hovering states, I wait for the waiting event and target the loading state, which is just there, with the showLoader tag, and in this state you expect the CanPlay event to go back to the playing state when the browser tells you that it's safe. There are many ways to pause a video. For instance, you can click anywhere on the video on a desktop, or you can click on the pause button, or you can press the space or the K characters. All of these possibilities are coded inside the state machine. In the playing state, we listen to the pause, toggle, video click if not touch device, and toggle all, which includes the keyboard. The toggle event is triggered by this button. It's just easier in the React code to just send the toggle button whatever the current state of the machine is, either playing or paused, rather than having to branch based on the current state to decide which event to send to the state machine. So instead of all of this, I just send a toggle event, and based on the current state, if it's playing, then it goes to paused. If it's paused, it goes to playing. This is the button. When you click it, it sends a toggle event, and based on the current state, it either shows a pause or play icon. The pause event is not directly triggered by the UI, but by the device controls. Indeed, the user can control your video not only through the UI you developed, but also from the device controls. Indeed, if I go to the controls of my Mac, I can pause or play the video from the device controls. The HTML video element has some play and pause callbacks that are triggered when the state of the video changes. It can be by you when you call video ref.play or pause, but also when the state of the video changes from an external trigger like the device controls. We can use these functions to synchronize the state machine with the state of the video element. We don't control the internal working of the video element, but the browser gives us the tools to do it properly and synchronize the video state with the state machine state. As we saw, the controls don't behave the same on a mobile and on a desktop. On a mobile, when you click on the video, it's to hide or show the controls. On a desktop, it's to play or pause the video. This is why you can see this transition, video click, which goes from the playing state to the pause state, if you are not in a touch device. We saw that the toggle event is listened to in the playing state to trigger a transition to the pause state. However, the toggle.wildcard event is also listened to. The reason is that we want to do something different if the toggle happens from the keyboard by pressing the space or the K keys. We go back to the video. If I try to click on the play and pause button, you can see the video plays or pauses normally. However, now if I press the spacebar, you can see there is an icon that appears at the middle of the screen. The same thing happens if I click on the video. This is to give an indication that something happened. If you click on this button, you expect the video to play or pause. However, if you press the spacebar, you may not be focusing the video, or at least you may not think that you are still focusing the video. So giving an indication is important. In the code of the machine, inside the playing state, as we saw, we listen to a bunch of events, and let's take a look at the special treatment for the video click and toggle.wildcard events. So we are raising an event. The name of the event is animate, and we specify a payload with the animation property. We will see later how the animation works, but a hint is that I'm using some parallel states. Once we are in the pause state, we execute the pause the video action. This action will pause the video by calling videoref.pause. As for the play the video action, we use an imperative function from the HTML video element reference. If you remember, the controls of the video player don't disappear if the video is paused. However, you may want to make them disappear, at least on a mobile. This is what the YouTube player does. So when you click wherever on the video on a mobile, which is simulated, then the control disappears. And if you click again anywhere on the video, the control appears. In the paused event, this is implemented the same way as for the playing event. We default to a showing controls state, which has a show controls tag. And when we click on the video, if we are on a touch device, we go to idle state. And if on idle state we receive this video click event, assuming we are still on a touch device, then we go back to the showing control state. The pause state is exited the same way as the playing state. When you click on the controls, or when you press the space or the K keys, or if the browser tells you that the video went to playing again, for instance, through the device controls. In the machine, in the pause state, if we receive a toggle event or a play event, we go back to the playing state. If the user clicks on the video while not being on a touch device, like on a desktop, the video will play again. And same thing for the keyboard. The difference here with those two events is that, again, we want to animate the icon on the middle of the screen. When the video plays, we expect the browser to send us a time update event, telling that the time of the video has been updated. We forward that to the state machine. In the playing state, we listen to the time update event and assign the new current time of the video to the context. Whatever the current playing state is, the user should be able to set the volume of the video, but although seek at any position of the video, or go backward or forward. These events are listened at a more global state and managed by the state machine. When the user moves the handle on the slider like that, this function is called, and a time.seek event is sent to the machine with the percentage of the seek operation. Then the machine receives the event there in the ready state, and it triggers an action with a pattern new to the XState 5 version. So the idea is to call the setVideoCurrentTime action and give it parameters. This is parameterized actions. So here I take the context and the event, and I say, okay, you will seek the video current time from the video player, the HTML element, to this. And then in the React component, I do video ref current time equals seek2. When you update the current time of the video element, it will try to load the data from this point, and you will receive a seeking event telling that it's trying to reach this point on the timeline. So on the HTML element, you can listen to this element and then forward the event to the state machine with the current time. And when I receive this event, time seeking, I assign the new current time to the context. The reason I do this in two operations is because, again, you need to take a defensive approach. You must take a defensive approach because the current time can change from the outside of the web page. You can use the controls of your device to seek at any position of the video. If we go back to the browser, you can see that it's updated. Let's talk about something really cool from the XState 5 version, enqueueActions. It's an action creator like the pure function from the 4th version. The idea is that you define programmatically which actions to call, like more actions to execute. Here I want to set the current video current time. Here I want to raise an event, and maybe you want to compute some values. Here I'm doing this because I don't want to compute the updated video current time when I go backward. I go backward by 10 seconds, and I don't want to repeat this operation in two actions because I want to set the video current time to now minus 10 seconds, and I also want to raise this event if some condition is matched. So you can use an enqueueActions when you want to group some actions and decide programmatically from some conditions whether to run them or not. Let's talk about the animation you can see on the middle of the screen here. If I go forward or backward, there is some icons on the left or the right side of the video. This is implemented in the state machine thanks to another parallel region. This is how you call a child state of a parallel state, or orthogonal region. This is another name. So for now, we have been checking the control state. Now we will give a look at the animation state. Both states happen at the same time. So the animation state can be in one state at a time, while the control state is also in another state. These things happen in parallel. In this state, we have some events like animating playing state, idle, animating pause state, animating backward and forward. And we have a bunch of transitions based on the animate events with some guards. The Stately Studio can't parse my inline guards, so this is why we have unnamed guards. In the machine, it looks like this. we have the playing state, the loading state, the pause state, etc. They are all wrapped under the control state. And on top of that, we have the ready state, which is a parallel state. And another state of this state is animation. Animation has the idle state, which is its initial state, and then the animating, playing, paused, backward, forward state, etc. These states have tags, animate action, animate playing state. As you see, we can have several tags on the same state, you just have to wrap them on an array. And then, when we receive the animate events, we have an array of transitions, with each transition having a guard. The first guard tells whether the event.animation property is playing, paused, backward, forward, etc. And after that, we target a child state. This is the dot means target the animating playing state, which is a child of the current state. On the React side, if the current state has the animate action tag, then I display this div absolutely positioned with these icons. So again, I check against the animate playing state, pause state, backward, forward tags, and based on that, I display an icon. When the element enters, I animate it with this ping animation. It's the same as the Tailwind ping animation, but in my case I'm using Panda CSS, which has the same ping. But I limit the animation iteration count to 1. If we want to animate the backward state, then I put all the content at the start of the flex element on the left, and overrise, if it's for the backward, it's on the end of the element on the right. Overrise as center the icons. When the animation is end, we can use this callback to run some logic. In my case, I send to the machine this playStateAnimation.end. In the machine, what it makes is that we go to the idle state. And because tags are no longer available from the current state, then these animations will just disappear. One interesting thing is how this animation may overlap. For instance, you can click several times on the forward key, and the animation always restarts. The same thing happens if you go to play, pause the video. What we want here is to restart the video from the beginning every time then we go to another state. For instance, if we play and then pause, we don't want to display the animation for the play while the animation for the pause should be played. So we can use this key trick with React to restart the animation from the ground up, and the animation will end, so we will receive this event. However, we need a key, and the key cannot be the current animation we want to play, like forward, backward, play or pause. Indeed, if you click several times on the forward key, then you want the animation to be restarted from the ground up every time, so we need something else. What I ended up using is the current timestamp. So every time one of these transitions is taken, I set a timestamp to the context. Like this, animation action timestamp will become new date to isostring, and in the React component, this is this timestamp I'm using to restart the animation every time the animation needs to play. Now that we understand how the animation works, we still need to check how the animation is triggered. This is thanks to the animate events, and as you can see, on the machine, every time I want to start an animation, I go raise an event. So to sum up, raise is to send an event that should be executed right now. So raise this animate event, and I can specify which animation I want to play. I have backward, forward, pause, and playing. So all is centralized. From anywhere on the machine, you can raise this animate event, and then the other parallel region will catch it and will start the animation. The last thing we have to check is the full screen mode. So when you click on this button, you go to the full screen mode, and then you can see the icon changed. And if I click on the ESC key, the escape key, or on this button, I exit this full screen mode. In the machine for now, we checked all of these transitions, but we still have to check the transitions below. The video player machine is, the root state of the machine is a parallel state. We checked the video state. Now we have to check the full screen state. So it has two states, off and on, and basically they will listen to the kind of same events. So this is like a toggle state. So first thing, initial states are off and idle. On the idle state, when we receive the full screen toggle event, I call an action set video full screen state with a parameter called set full screen true. And in this state, I'm waiting for the acknowledgement of the browser. And when the browser sends me this full screen expanding state, I go back to the done state, which is a type final state, represented by this double square. And when this state is reached, the off state is considered done. So the undone transition of this state will be taken, and it will lead the state machine to enter the on state. Again, when we are on the full screen mode, if we receive this full screen toggle event, then I call the set video full screen state action with the set full screen property set to false. I go to the waiting for acknowledgement state, and when the full screen exited event is received, again, I use a final state, done, to go back to the off state through this transition. So this is the basic behavior, but more things can happen, like, for instance, the full screen mode may be exited while we wait for the acknowledgement of the full screen mode being activated. This may happen, so we need to take care of this state to prevent race conditions. So when the full screen is exited while we were waiting for the full screen to be expanded, then we go back to the idle state, and going to the full screen mode may also fail if, for instance, the full screen mode is not supported on the device. So we need to take care of errors there. And same thing happens for the on state. So if we want to exit the full screen mode, but in the meantime it's expanded again, so we need to stay in this state and manage errors. Another thing can happen, we might be in the full screen mode deactivated, so the full screen mode is not activated, and without the user taking any action from the UI, the full screen mode may be activated. So you need to take care of these transitions, and this is by listing the full screen expanding and exited events globally on the global state itself. In the code of the machine, directly on the root state of the machine, I set this type parallel, so the whole machine is considered a parallel state. Then there is this video state, which has the stopped, etc., all the states we saw until now, and then the full screen state, which manages the full screen mode. One interesting thing to check is again this parameterized actions in XState 5. So you give the name of the action and you give some parameters. This time parameters are static, contrary to the last we checked to set the current time of the video. So this is why the Stately Studio is able to identify the parameter, which is false in this case. The full screen toggle event might be sent by this button, which is at this corner of the screen. So this is a button, and again you can use the current state to check whether you need to display the arrows pointing in or pointing out icon. Another interesting characteristic of the parallel states is that the machine is in several states at a time. So this is why you can use an object here to match the state. So you can be in one state of the full screen mode, like on, and you can also check if you are on another state of the video state, like ready, I don't know, etc. like this. You can check that. This is the power of using an object in the matches function. You can check several things at the same time. In the React component, I override the definition of the set video full screen state action, which takes the set full screen parameter. And this is where things get worse, definitely, because it doesn't work the same way across all browsers. On iOS, you have to use this WebKit set presentation mode function. So usually you do request full screen or exit full screen. On iOS, you need to use the video element, WebKit set presentation mode, and it takes a string like full screen, inline, or picture-in-picture if you want to support picture-in-picture. To listen to the full screen mode changes, I've been using some use effect hooks. So one for iOS specific full screen mode. So when the video elements receive this WebKit presentation mode changed, I call this callback, which gets the presentation mode of the element. So this is not typed correctly because this is an unofficial attribute, but the types are this. And if the presentation mode is inline, then the full screen is exited. But if the presentation mode is full screen, then it means the full screen has expanded. Same thing for the natural way of doing this. So I listen to full screen change and full screen errors events on the document, and I send these events. So if the full screen has changed, if there is a full screen element, so this is either null or an HTML element. If this is null, then I send that the full screen has exited. Otherwise, if the current full screen element is the video container ref, then it means the video has expanded. I think it's important to have it check because if you don't, you might think you go full screen, but it's not your video player, it's another one, or another instance of the video player. Another thing I can add there is that I had to manage just a bit because I'm not really strong with that. I had to manage the focus by saying that the video container ref can receive the focus with tab index equals -1. That way, the element is not targetable by pressing the tab key, but the element has the focus when it needs to. For instance, when I click on the element, you can see that there is a blue ring around the video. This is because the element has a focus. I have so much more things to say about this video player example, because it took me so long to build it. But I think I will stop there. If you have any question, just ask them in the comments of the YouTube video. And yes, go check the example on xstatebyexample.com. And if you have any other idea of component you want me to build with XState, please tell me. I will try to build them and to make a video about them to help the community, yes, understand how XState can be used to solve complex problems like this one. Thanks for watching. I hope you like this. It was a rough review about my code, but yes, tell me in the comments if you liked it. Bye.